Let's go ahead and go over scatter plots. So a scatter plot displays pairs of numerical values to show whether and how two variables are related. Every point on the plot represents one observation with an x coordinate and a y coordinate. Now there's three kinds of relationships that these variables can have. First is positive, and positive, simple as it sounds, as x increases or y increases. Think about it as time studied and relationship to test score. If you study more, if I spend more time reading my book, chances of my test score to go up are higher as well. Now let's look at negative. Negative is going to be the opposite. As the x decreases, the y increases, or as the x increases, the y decreases. Let's say you spent some more time in the gym maybe over time. That's going to maybe bring down your weight. Finally, we have no correlation. And no correlation is exactly like it sounds. The two variables aren't going to have anything to do with each other. We could say maybe your chances of becoming an Olympic athlete in relation to your test score in geometry. It's not really going to have anything to do with each other. The strength of relationship has three options too. You can have a strong relationship, which just means it's strongly correlated. You can have a weak relationship, which means it's weakly correlated, or a moderate, just kind of somewhere in between there. Let's go ahead and use a scatter plot here. We'll say the x-axis is going to be the hours studied, and the y value is going to be your actual score. Now, if we look at these points, we see there's a big cluster of points up here. So it seems like as hours studied increase, test scores also increase. We'd have a positive correlation here. That's the first thing. Next, we'd go over the strength. Now, the cluster looks pretty tight here looking at some of these points. We'd say it's a strong correlation. Now, let's take a quick look at any outliers. We've got a few scores out here, all the way out here. It seems like very low hours, but a high score. Those would be our outliers, and that would be considered unusual because of that. Then we can actually go ahead and interpret our scatter plot here. So looking at it, we could say more study time is associated with higher test scores, but the relationship isn't perfect, and there might be other factors that influence the scores. Example, somebody cheated. You could have somebody who studied for a very long time and got a low test score, and maybe they had an off day. Once you have your scatter plot, you can start to build out your line of best fit. We also might hear it called a regression line or a trend line. It's the line that best represents the overall pattern of the data. It minimizes the distance between itself and all the points. So your line of best fit is usually going to sit as close as possible between as many points as possible. The equation is always going to be the same as we see for our linear equations, y equals mx plus b. Your b is going to be your y-intercept, your m is your slope, and your x and y are going to be your independent and dependent variable respectively. Let's take a look at y equals 4x plus 55. The y-intercept would be 55, meaning that if a student studied 0 hours, the model would predict that a score of 55 points would be average or attainable. Here, the slope is 4. This means that for every additional hour we study, the test score increases by about 4 points on average. We can use this to go ahead and make some predictions. Let's say the question said, if a student studies 6 hours, what score does the model predict? Well, we could take our equation here, and instead of writing an x, I'm going to go ahead and write our 6 in. We'll do 4 times 6, which is just going to give us 24. 24 plus our 55, we'll get 79. So if a student studied 6 hours, they'd most likely get a 79 on this test. And that's how we use scatter plots to find our values. Now, there's going to be two kinds of predictions we can make. We'll call them interpolation, extrapolation. Interpolation goes inside the values we already have, in the data that we know for sure. It's going to be quite reliable and the most reliable form we can use since we have data points that'll be right there. Now, extrapolation predicts outside of the range of data. Now, it's still useful, but it is less reliable because we don't know for sure that the relationship is the same at values that are going to be higher or lower than what we can see. So keep in mind, correlation is not causation. Let's go over the two real quick. Correlation means our two variables are related. Causation means one variable directly causes the other to change. It's very important to know the difference between correlation and causation. Just a few tips. We know y equals mx plus b. We know that m is going to be our slope. A positive slope means there's a positive correlation. A negative slope means there's a negative correlation. Strong correlation does not mean causation. And outliers can affect the line of best fit significantly, so keep them in mind when you're making your line of best fit.